Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
I'm Caitlin. For math homework help, call it in Bakersfield 636-4357. Everywhere else, call 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
All right, nicely done, Caitlin. So where do you attend school?
Stockdale Elementary,
And what grade are you in?
6th.
Have you been at Stockdale for a long time?
Yeah, since kindergarten.
Oh, good. So you're going to miss it next year.
Yeah.
Do you think you'll miss it?
We'll see.
Okay, yeah. Well, you got to wait and see, right? So as we were going through the opening, you said that you saw Landon. That's your brother.
Yes.
And he was on the show. So he's older than you.
Yeah.
And you help him with his homework?
I don't know. I can, probably.
Oh, okay. So you can. Does he often need help?
No,
No, okay. But you're willing to help.
I can try.
Do you think he would help you with your homework?
It depends on if I'm nice to him.
Oh, okay. So you guys got a little thing going on. You know.
Yeah.
All right, good. So how's your 6th grade year going?
Pretty good. The math part of it is pretty easy.
So what kind of math are you doing in your regular 6th grade classroom?
Right now, it's kind of all about fractions and rational numbers.
And what can you tell me about rational numbers?
They're
Other than they're not irrational.
they're sometimes whole numbers, sometimes mixed numbers. They're, I think, sometimes negative,
So
I want to say.
have you learned about irrational numbers yet?
No.
Okay, so that's something to look forward to then, right?
Yeah.
Is there anything that you've done in 6th grade that's been kind of difficult where you're like, you know what, maybe we could have spent a little more time on this?
Maybe absolute value.
Okay. And you understand absolute value, what that means, correct?
Yeah.
So if I had inside the absolute value symbol a -3, what would the absolute value of that be?
3.
Okay. Now what if I had -3 plus 2? What would the absolute value of all that be? So -3 is inside the signs, and then I have a plus 2 outside of it.
I'm not sure.
Well, what's the absolute value of -3?
3.
Plus 2.
Oh, 5.
Okay, so don't make it more difficult than you think it is, all right? Are you ready to help me out with the social media problem of the day?
Yes.
All right, let's take a look at it together. So it says, what is the answer in simplest form? So when we see this, what do you notice? What's the first thing you notice that comes to mind?
There's a negative fraction.
Right, there's a negative, right? So that obviously is going to catch your attention. So you see something negative. So how do you want to proceed with this?
Make them like.
And how would you make them like?
Well, 5 and 3 are both factors of 15.
Good.
So 5 times 3 is 15, and 3 times 5 is 15.
Okay.
So then you would have to do the same to the numerators. So 3 times 3 is 9 over 15, and 1 times 5 is 5 over 15.
Okay. So we would have a 9 over 15 and a 5 over 15.
Yes.
And what do you want to do with those?
Well, I would say add them, but I think there's a specific way you would have to do it.
And what do you think? Well, why wouldn't we add them?
Well-
Isn't there an addition sign up there?
Yeah.
Okay, so we'll add them.
So,
Is the negative throwing you off a little bit?
Yeah.
Okay. So we're just going to take a negative number and we're going to add it to another number.
Right.
So we have -9/15 plus 5/15. So what do you think? So we know it's 15ths.
Right.
So just take the numerators, -9 and +4. So if we had -9 plus 4, where would we end up?
Plus 5.
Plus is 5.
Oh, plus 5. Did I say plus 4?
You did.
Oh, I'm helping you out a little bit.
It would be,
One step ahead.
So you're at negative 9,
yeah.
and you're going to add 5.
So negative, wait, no. Yeah, negative, oh, this is simple. Negative 14.
Okay. So you're at negative 9. So get it pictured in your
Wait,
head.
okay, yeah.
Now, if you're going to add, are you going to go closer to 0 or farther away from 0?
Wait, closer.
Closer.
Yeah, closer,
Okay.
yes. Okay,
So you're at negative 9, and you're going to get closer to 0.
yeah.
How close are we moving to 0?
5.
So where
Oh.
are we going to be?
Negative 4.
Okay, so sometimes it's confusing because you're trying to do it in your head without
Right.
seeing it and stuff like that, and writing
Yeah.
it down. So you're sure
Yes, I'm
negative
sure.
4/15ths,
Yes.
because it's got 4/15ths up there. You don't want to go with A?
No.
No? That was a fast no. Now what about 13/30?
That just doesn't make sense.
Okay, that's fine. What about negative 2/8?
No.
Why do you think that's even up there? How do you think they came up with that answer? Can you analyze that problem and see why they would come up with negative 2/8?
Well, I would originally say they divided it by 2 because 4 divided by 2 is 2, but 15 divided by 2 is 7.5.
Okay, so forget that there's any answers up there as far as the 15ths.
Okay.
All we have is the problem, and some kid goes negative 2/8. What do you think they did to get negative 2/8?
They probably subtracted.
Negative 3
no,
and 1.
they probably subtracted negative 3 and 1 because they looked at the negative sign.
Right,
And they added 5 and 3 because they saw the positive.
right.
the
So
addition
what
sign.
that is what you just did is error analysis. Because there are going to be times when they put something up there like that you sometimes might go, hey, you know, that's kind of a ridiculous answer. But there are some kids that will understand how to work fractions and get common denominators, and they could see that as a plausible answer. So last time, you're going with C.
Yes.
All right, let's take a look at it. C is indeed correct. So it took a little bit, but we got there, right?
Yeah.
All right. 636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, so today's Math in the News has to deal with today's date. So today is October 15th. And October 15th, there's some pretty fun things about the number 15. So first of all, let's take a look. And the number 15 is a triangular number. So there are some students going, well, I don't understand what a triangular number is. So let's talk about triangular numbers first. An integer that can be represented as a triangular pattern where every row contains one more dot than the previous. So the first triangular number would be 1. Then we add another dot, so we have 2 dots altogether. So 3 is a triangular number, okay? So let's continue. So we can see that we add 2, then we add 3 more dots. So 6 is a triangular number. We go down, add another dot. So now we have 10 total dots. So 10 is a triangular number. Scott wants to do a little bowling, right? Yeah, all right, there you go. So that'll work also. The formula to figure out what a triangular number is, if you want to find the nth triangular number. So let's say we want to find the 4th. Well, let's do that since this is an example up here. So we're going to go 4 times 4 plus 1. So 4 plus 1 would be 5. 4 times 5 is 20. 20 divided by 2 is 10. So we can see the 4th triangular number is in fact 10. So another way to rewrite that was on the other side, but here we're going to take this and we know that we want to find our nth triangular number. So we're going to take half of this. So we want to find the 5th triangular number. So we simply substitute 5 where the ends are. So we're going to have 1/2 5 times 6. We know 5 times 6 is 30. 1/2 of it is 15. So the 5th triangular number is 15. A fun little thing right there. That's today's Math in the News. We'll be back with more right after this.
I'm Sanay and I'm in Reagan Elementary,
Today I'll be doing factorization in algebra. So first off, we can take this x squared and put it into two parentheses like this. Then we have to find two factors that multiply to 2 and add to 3. 1. So now we find two factors, and we just gotta add them to equal 3. Now finally we just gotta place them like 2 and positive 1. A way we can check this is we can take x times x to get x squared, x plus 1, which equals x, plus 2 times x, which equals 2x. When you add that, you get 3x. And when we multiply 2 times 1, we get 2. Thank you.
Yeah, nice job of factoring right there. In studio with us, we have Caitlin. She is a 6th grade student from Stockdale Elementary. Right now, we're going to check out KCSOS STEAM and Expanded Learning and check out a little science.
All right, hey, so today we're here with Michelle. Down here, we're going to do some science, and Michelle's from KCSOS STEAM and Expanded Learning. And today we're going to be doing, 3 projects?
Yes, today we have 3 featured projects that we're actually going to be doing here in the room today, but it's all a part of getting the word out about our special event that we're having this weekend called STEAM on the Streets.
Yes.
Here at Kern County Superintendent of Schools. It's an event being put on by the STEAM and Expanded Learning Department here at KCSOS, and we're actually doing 3 of the activities here in the room today. The event is on Saturday here in the Breezeway down here on 17th Street, October 19th. The event is free flow. It'll run between 9 and 11:30.
All right, fun.
And these 3 activities are just 3 of the activities. We're going to have 22 total activities going, and some of the other things that we'll be doing that won't be featured on the show today include there'll be a wind tube exhibit, there'll be some sensory sand playing, there'll be another activity where students can play around with shadow and light, and pumpkin painting. Students who come will get a backpack and some books. And most of the activities that we're doing today here in the room will be a part of what we're calling our maker space. We're going to be doing some low-tech maker space work, which is what we're doing right now. And right now in the room we're making buttons.
Nice.
We're emphasizing that A.
I was going to say, what would the STEAM stand for?
Yes, science, technology, engineering, art, and mathematics. So we're starting today with a little art activity with a little bit of design thrown in, and you could say it's a little bit of engineering with our low-tech button maker machine over there. All right, so if we have a couple of students, let's start with you. You want to tell us a little bit about your button?
I did do the math colors, and I wrote do the math in
Okay, and it looks like you're ready to put your design in the button maker. We'll take you over there in just a second. If we can take a look at what they've been working on previously before they cut, you could tell a little bit about what you're doing there.
So I love science, so I wanted to make my button mostly science related.
Yeah, it's looking good, and you've got our official event logo there. That's going to be quite the keepsake. And how about you? What are you doing?
I have this little imaginary character, so I made him, and also STEAM at the top.
Very nice. So does your imaginary character have a name?
Happy.
Happy. Very nice. And how about you?
For me, I did these little colors because I like them, and I also like to draw my own designs just outside the border.
Okay. That's fantastic. So how about if we have the 3 of you that are ready, you can go ahead and get up, bring your artwork, walk around the back side of the table, and let's come over here to the button maker. Ooh, it looks like Olivia's ready too. Get Olivia's button made too. And we're going to put our button maker in the right position. You want to help me pull here in a second? We got to put the top of the button down first, then put your artwork in. This is the top. So do you want this to be the top of the button, like oriented that way?
Yeah.
Okay, how about if you take our plastic cover there, drop it on top, make sure it gets in there all cozy, push it down a bit. Now, for the magic, we're gonna slide it over. And you wanna help me push? Ready? Put your hands on there too, because it takes a lot of muscle. All right, so let's put our back of our button, drop this in that way, into that little slot there. And let's straighten it up so that so your design is correctly oriented. Now, if you want to take that circle and just slide it over. Oh, and you know what the good part is? Look, it was like even a little mini magic trick.
Yeah.
Where'd it go?
Probably like down here.
Okay, well, you ready? Let's push again. Ready? Want to help me? No, gotta push good. Now, push it back that way. Ta-da! There you go. You can grab your button. All right, you can take it back over to your seat. Who's next? Were you watching? Let's do you next. We talked to you on camera. So, you ready? All right. So, did you watch?
Okay.
Okay, so let's push our button maker over. Drop that in. Right there on that side. Put it down there in the grooves. All right, next one. What goes next? Do you remember?
The clear thing, yeah.
All right, put clear cover on top. There you go. Get it all down in there. Ready? Help me push. Whoops.
I was like,
I was confused. Anyway.
Wah, wah, wah.
Anyways.
There we go. Let's redo that. Maybe they can edit that part out. Ready? Here we go. All right. Grab a bottom or a back.
Or anything.
Drop it in. Put the pin side down. That's gonna. There you go. Flip it over. Pull it out. Flip it over. There we go. Let's put it that way so it goes on. So your button is straight because that's the top. Now slide it over. Oh, it's gone! Yay! We still did it right, even though I did a little boo boo there. Ready? Okay. Ta-da! Ta-da! Yay!
That's cute.
All right. Let's do another one.
All right.
All right. Let's drop get it slid over. Put that in there for me. Put your artwork in there. Slap your plastic on top. Get it in there. Make sure we slide it over. Boop. All right, ready? Help me push. There we go. Put your bottom in. Put the little pinny side. That part goes down. Drop it in.
So Michelle, as you guys are finished
it
in
over.
this, what is your next project you're going to
The next thing we're going to do is our copper tape card with a light up LED bulb with a little spooky Halloween theme.
All right, that sounds
And
great.
look at that.
Yay,
Oh,
that looks good.
wah, wah, wah. We'll have to try that one again because I don't think we pushed hard enough.
Oh, we'll try it again.
But we were 2 out of 3, not bad.
All right. Okay, so these kids will finish up with these buttons, and then we'll get back to making our LED light shine, right?
That's right. We'll
All
get
right.
going on that
Back
one.
to you, Mike.
Thanks for that, Sam, and thanks to Michelle using her muscles down there with the kids, and also a magician now, I see. All right, Caitlin is a 6th grade student from Stockdale Elementary in studio with us, and you and Scott are going to work on a fabulous problem I came up with for you. So, take it away, read it, and then Caitlin, talk about how you'd like to solve it.
Go get him. What does it say?
A band of 10 pirates are going to disband. They have divided up all of their gold, but there remains one giant diamond that cannot be divided. To decide who gets it, the captain puts all of the pirates, including himself, in a circle.
All right, so you want to draw this circle before we get the rest of it? Because it looks like there's going to be more details here, right?
Yeah.
You know what disband means? It means they're all going to not be a group anymore,
Right.
right? All right, let's draw a circle of 10 pirates. Does that 10 pirates include the captain, you think?
Yes.
Sounds like it, right?
Yeah.
So maybe we got to delineate him with like a C or something, and then the rest of them can just be an X or an O or whatever it
Okay.
happens to be, all right? You want to draw yourself a circle there? Okay, so there's our circle of pirates. Where's all the pirates? Okay, there's the captain. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's all we need, right? Because we got the captain as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh, that should space a lot better. Oh well.
That's all right.
It's
No
okay.
big deal. We're okay so far. Those are in kind of a circle. They could be in a circle. All right, so what else? Well, how's this going to work? They have this one big diamond, right? One big diamond over here. I don't know if I can draw a diamond, but there you go. That guy right there. Everybody wants him. All right,
Okay.
so what are we going to do? Go ahead.
Then he points at one person to begin. This person steps out of the circle, takes his gold, and leaves. The person on his left stays in the circle, but the next person steps out.
Okay, so whoever he points at, right away they're bummed, right? They don't
Right.
get the diamond, they got to take off.
Right.
So that makes a big difference about who he points at first, right?
Right.
Okay, go ahead.
This continues with every second pirate leaving until there is only one left. Who should the captain point at if he wants to make sure he gets to keep the diamond for himself?
Because the captain's selfish, of course. We know he wants to keep the diamond. So what do you think? Do you have a way that you might want to go about this? How do you want to start? So let's say that, let's just make sure we're super clear here, right? Let's say that this guy right here, he gets pointed to,
Okay.
right? And then, so this guy would be out. Or sorry, he would
No,
be
he would be
out,
out and
he'd
then-
be in, he'd be out, he'd be in, he'd be out. Like, that's how we'd go, right?
Right.
Okay, gotcha. Just want to make sure we're clear with that part. All right, so where do you want to start? Let's at least have an educated guess. We can guess any of them, right? But let's have an educated guess and just maybe a reason, even if it's not right. Why would you pick that person?
Well, if you start here, this person's going to be out and he's going to stay in.
So
at
for the
least-
first round, he'd be skipped, right? Yeah, at least for the
Yeah.
first round around. That's a good idea. I like that. He
Okay.
certainly doesn't want to point at himself. That'd be a bad deal.
Right.
Okay, so let's say that he points at that person right there. Okay, and then, so is that person in or out?
out.
They're out. Okay, go ahead and cross them off. Gotcha. So then, we're going to the left, right? We're going
Yeah.
this direction. I like it. Okay.
Okay.
So captain's in.
Right?
Who's out next?
Him.
Okay.
He stays, he's out. He stays, he's out. He stays, he's out.
Okay, we've gone around once.
Right.
What's going to happen next? He stays. That person's gone already.
So he's out. So
Ah,
that doesn't
wouldn't
work.
work. Okay, so I like the theory because in the first round, the captain would definitely stay. Right.
I'm wondering if maybe, since the first time he was out, you start with this one.
Okay, so I'm going to see if we can back us up here, keep your amazing circle that you drew, and say we're not going to start with that guy. We're going to start with
Him.
this one, right? Right there. Okay, let's see what happens.
Oh, wait.
That wouldn't be a very good idea
Oh,
at all.
no.
Captain would be out on the second one. Well, that
So
didn't
instead
work
of
either.
going to the right side of them, how about if you go to the left side of them?
Ah.
Oh, okay.
Just a thought.
So at least it'd be a while, right? It was a good thought, right? At least if you started here, at least it'd be a while till it came back around.
Right.
But let's figure out, how about this theory? If we're going to the left side, like Mike suggested,
Right.
okay, let's figure out which one of these two would be good where it would skip him, right? Would this one skip him when it came back around, or would that one skip him? Let's just go real quick, right? So out, 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 out.
In.
That's
Oh,
right.
out.
So that one will be out, right? So what do you think? Should we point at the first one and see what happens?
Yeah.
All right, let's point at the first one. All right, let's cross them off as we go. So that one's out, 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 out. Oh, captain's in for another round. Let's see what happens. Out, out, skip. Oh, so close. We were down to the final three, but you still can't cut the diamond in 3 spots. Okay, so before I erase them all, let's remember, it's not this one, it's not that one, it's not that one. We only have a couple of them left. What's their next educated guess? Because my thought is this one wouldn't work because he'd be out on the first round, right?
It's like this one.
We tried that one, it didn't
right.
work. Oh, it's like that one, that's right, good point.
I want to try this one.
Okay, I like it because we at least be one a
Well-
little further, right? Yeah,
Yeah.
mm-hmm,
Yeah.
yeah, okay. Arrows there. Out, out, out. No diamond for you. Skip. Yep, good. He made the first round. That's good.
Okay, so that one.
So out, in, out, in, out, in, out, in, out.
Aw.
Oh, we're down to
So
one.
while you guys keep on going with that, what we're going to do is we're going to reward you for your great effort thus far, because all I want you doing is thinking about this and seeing if you can find some sort of a pattern. So you've got yourself a meal courtesy of our friends at Chick-fil-A, so congratulations on that. Hey, we'll be back with more right after this.
Hi everybody, welcome back to Culinary Corner and Do the Math. Today we're going to be mixing bread. Now, I have laid out here kind of our first steps in the process. And what we're looking at here is just regular tap water. I have some active dry yeast, and I have some sugar. I think most of you know what this means, right? We're gonna proof our yeast, but do we really have to do that? Let's talk about it. The reason that we proof yeast is that we want to see if it works. So if we're talking about proving things, right? Proving a point, you want to prove that it makes sense. You want to give the reasons why it makes sense, why it works, right? Now, if you store your yeast properly, which means in the fridge, fresh from a vacuum sealed container, you probably don't need to prove your yeast anymore. So you can just mix all of your liquids together with the yeast. So what we're going to do is we're just going to put all these ingredients together and throw them in our mixer over there. Now, the reason that we have this pitcher on there before we put our scale on is because if we take it off, you can see the scale goes down to negative 505. The way you can fix this is by hitting the button tare. Tare is kind of like a reset to 0. So we do that, we have 0 grams on our scale again. All right, so let's get our water in there. We're looking for 1,000 grams of water, which is also a kilogram. So we know that our metric system is based off of a system of tens. So 1 gram to 1,000 grams being 1 kilogram, that's the prefix. So what we're doing here is we have this tap water in a container, and the reason we have this tap water in a container is to degas it. Most tap water straight out of the tap is going to come with a lot of gases that are volatile. And what that means is that they're going to evaporate from the water. So now I have my 1,000 grams of water. I'm going to add my yeast to my water, not to my dries. There's a big reason for this. My dries will contain salt, possibly sugar, but definitely salt. Every bread recipe will have salt in it. Now, there are a few things that kill yeast. Temperature, high temperature. Acidity, high acidity, or low pH is another way of saying that. And salt. Salt will murder your yeast. It kills it on contact. So we put our yeast with our water, we save our salt for our dries. Now I'm going to look for, I'm going to tear my scale again, and I'm going for 12 grams of yeast, which is a lot more than you think it is. Perfect. Rubber spatula, and we're going to get this in the mixer. All right, so we've got our water and our yeast, and we're just going to make sure we scrape down the sides here and get that into our mixing bowl. Now, the reason that we're putting in our water and yeast first is it's way easier to mix a dough when the wet part is on the bottom and the dry part is on top, because it won't stick as much. Time to get our flour. I feel like this is a good time for me to mention why I'm using a scale instead of using a measuring cup.
Always nice to see Miriam in those culinary calculations. We do have another opportunity. We'll head back downstairs and check out what they're doing with their copper wire.
Okay, so we're back to our next project, and so this one is light up.
We're
LED
making
lights.
an LED light up circuit card
Okay,
with our seasonal theme going there.
very cool.
And here's our lovely cover. And whoop, surprise!
It's
It
lighting
lights up. But there's a little secret inside the card. Inside the card, I'll open it up and let you behind the
Oh, well,
curtain.
can you tell us what materials that
Yes.
you've used for this?
So we have just some regular little cardstock. We got some little seasonal stickers, an LED light bulb, a little small LED light bulb, a little like watch battery, coin battery there. We have some copper tape. And you can see on the back there, I've got some Scotch tape too to kind of hold it all together. And when my circuit is complete, my light bulb lights up.
Very cool.
And when it's not, when I break contact there, it does not light up. And the students right now have all the materials that they need to make the card. And they've started working on decorating the cover, the front of their card. But let's go ahead and go inside. And so students, if you open up your card to this inside spot where my card, where I have my copper tape, where my circuit exists, on that side there. And I've given you just enough copper tape and a little bit more, just enough plus a little bit more, to make a circuit about the size as mine. So if you could all take a look at the size of my circuit, that'll help you not run out of copper tape. I have extra if we have to use extra copper tape, but if we, it'd be great if you could complete the circuit with the amount of copper tape that you had. And so what I would like everyone to do is, can I use yours as a demonstration here for a second to get it started? Before we went on camera, we got started a little bit and we opened up our tape just a bit. So if you could, and this is kind of the tricky part because it wants to get stuck back on itself. But we're going to open it up a little bit, just like that, over there, so we can get started. And just kind of watch me. And I'm up toward the top, about that much. Move over here so you can all see me. And I'm about midway across the card. And I'm going to go about that far with my copper tape across the top. And there's really no way to mess this up, so go ahead and start pressing your copper tape on your card. Now, something that I learned today about the copper tape is that adhesive side, that sticky side, makes the copper not conduct electricity. So we want to complete our circuit without tearing the tape. So when I get to the corner, I'm not going to cut the tape. I'm going to peel the white stuff back a little bit. And I'm going to make like a square corner on top of itself. We got some adults around the room who are helping us out. See how I turned my corner there? Can you guys see that? So you can go ahead and start taping your copper on and then turn that corner at a 90-degree angle. Oh, it's okay. You can just keep going and tape it right on there. There you go. Move it back just a little bit and then turn your corner.
Can you do whatever side?
Yeah, it'll be fine. There. Oops. Am I on there? Oops. We gotta go this way. Get it to stick. Right, there you go. Now keep going. All right, so I turned my corner. And then I'm going to keep going, pressing and pulling the white back till I decide I want to turn the corner again. And then do another right turn corner, trying not to tear your tape. Pull my white back. All right. So we've gotten our copper tape about halfway on.
I have a question.
Yes.
Okay, so if they want their, does it matter where, does the light have to be at the end of the?
We're going to work the light in our light bulb into the center at the top. It's actually going to go at the top where we started.
So wherever you started, that's where the light's going to go?
Yep. And if you are interested, Are we doing okay? All right, I see we're moving around there. Get it going. And you'll notice that here on my sample, I only went that far. Ladies over at the far table, I only went that far. Looking so good. And you know, if you go too far, it's fine. You can pull the tape back a little bit as needed. And looks like if you are interested, this is as far as we're going to be able to get on camera today. But for those of you out in TV land, if you're interested in seeing how this card project ends, come out to Steam on the Streets on Saturday morning here on October 19th, out on Steam on the Streets.
Okay. So October 19th from 9 to 11:30.
9 to 11:30.
Right. So you'll be able to see these projects, do these projects, along with 20 some other projects. Okay, so we'll let these kids continue on with this project.
And we'll clear this one, and we have one more.
Okay, all right. So Mike, back to you in the studio,
Hey.
and we'll keep working here.
All right, thank you, Sam, and thank you, Michelle, also, and out there in TV land, they're getting ready to light it up downstairs. So you guys finally found the answer. So Caitlin, what did you have to do?
So it was kind of process of elimination. We started with this one because we thought it would skip the captain, but on the second round around, it knocked him out. Right. So we kind of just went around the circle, but we did figure out that even numbers were bad because even numbers always knocked him out. So 2, it would knock him out on the first round. Right. So we figured out that odd numbers were the way to go. So then we just kind of started with all the odd numbers and figured out that it was 7 that left the captain with the diamond.
Good. So there were an even number of people, including the captain. There were 10 people. You found out the even number to start on wasn't good.
Yes.
So you came up with 7 as your answer.
Right.
What if we had another pirate? So there were 11 people, so 10 pirates and the captain. Do you think that would still work? Good. I'm glad you're thinking about it, because that's exactly what I want you to do. I want you to think about that, because right now we're going to go and check out more bread. You ready? All right, let's check it out.
Okay, so now that we're done with our water, let's focus on our dry ingredients. So we have sugar, we have salt, I have bread flour, and I have 2 local flours from Fat Uncle Farms. Now, the reason we use different flours in bread is because each flour has a different protein content, which translates to a different gluten content for the finished product. When you're making bread, you want a strong flour. Strong just means high gluten. So we're looking at 12 to 14% gluten in this flour. Now, if I was making pastry, I would use something with a softer flour, like this rye. Now, this rye is milled fresh in Wasco by Fat Uncle Farms. You can tell, it looks a little less fine than what you would see coming out of a bag, right? It's a little more coarse. It's got more of that whole wheat kernel and chaff in there. So today, since we're doing bread, we're going to use our high gluten bread flour and a different flour from Fat Uncle Farms, which is their high gluten Joaquin Oro. Joaquin Oro is called a hard red. Now again, we know that hard means that there's a lot of gluten in it. So we know there's a lot of gluten in here, which we'll compare to our bread flour. And it's red because the actual kernel of the wheat is, well, red. So Joaquin Oro flour and just a plain old white bread flour. You can see the difference there. It's finer, it's powderier. Now we're going to do mostly bread flour for this kind of roll, and then we're gonna give it a little flavor with our local flour. So we're starting off with 500 grams of the white bread flour. I feel like this is a good time for me to mention why I'm using a scale instead of using a measuring cup. When you measure something with a measuring cup, there are different results that you're going to get for weight. Let me give you a for instance. If I just scoop my flour like this, level it off with my hand, right? That weighs 161 grams. Let's cancel that out. Now, if I'm a scooper and a packer, let's say I like to pack my flour on the side of my container, which a lot of people do, right? Now, that last weight was 161. Do we think this is going to be higher or lower? Significantly higher. It's a solid 13 grams more, right? So we don't, over time, that's going to add up. We don't know how much it'll be. If I do 5 cups like this, I'm adding in an additional 50 to 60 grams. We don't want that. We need to be precise. So we do it by weight. All right, now that I've added in my white bread flour, I'm going to add in about 750 grams of the Joaquin Oro from Fat Uncle Farms. There we go. And last but not least, we're going to add in our salt and our sugar. Now, super strict professional bakers, to avoid that issue we talked about with the salt earlier of killing the yeast, they will add their salt at the very end after everything else has been mixed. But for our purposes, we're pretty good now that we've mixed our yeast with our water. So we're going to tear this out, and we are going to add 40 grams of sugar. And we're going to finish off with about 15 grams of salt. To avoid mistakes, a lot of people will recommend that you scale everything out into separate containers and then mix them in the bowl. And I think that's a great rule. But I've done this quite a few times, so we're going to go with it. All right, so now we have all of our dries, and we're just going to add them to our wet solution. And again, I go dries to wet because I don't like to deal with dough that sticks. Now, depending on the kind of mixer you have at home, you are going to be able to set it for speed and time. So with this big guy, we would set it at a 2 to start, and now that translates to about a 4 on a home mixer, 4 to 6, medium on other mixers. And we're just going to set our time for 8 minutes just to get everything incorporated. This will shut off by itself, but you may need to use an actual kitchen timer at home. What you're looking at here, all these little strands, these spots where the dough is breaking, all those are gluten molecules that are coming apart.
Well, I tell you, there's nothing wrong with the bread that Miriam bakes, and I'll tell you, that's some good stuff down there at Radio Sandwich. Right now, we're going to head back and see what they're doing downstairs. I think that they've got another challenge for the kids, going along a track, if I'm not mistaken. Is that right, Sam?
Yeah, so now we're moving on quickly to the next project, and this is the T, right, of
Yes,
STEAM?
this is the T in STEAM, the technology piece, and we're working on a little very basic coding activity with some color tiles that are pre-coded with some direction code in them, and you can see the green, they know that the green means go.
Okay.
And they just learned that red means stop.
Okay.
And all the other colors refer to other directions.
Okay.
Right turn, left turn, spin. There's all sorts of various sorts of movements that
Right.
the tiles do.
Okay.
Now, our mission for this activity, though, right now they're just playing around, learning about, figuring out what the different tiles mean. But ultimately, our goal is to then, once we know what all the color tiles do, is to lay the tiles out in such a way that Indy will make a square and stop, or make a figure 8 and stop, a zigzag and an up, back, and through. But they're not going to be able to do that until they know what each of the tiles do.
Right. Okay.
So let's see
right.
what each of the student groups have figured out so far. So ladies, can you tell us a little bit about what you've learned about the color tiles so far?
So we tested all of them out, and purple's like, here, get green. Purple's like the car spinning around, like dancing, like a car dancing, as you can see here. And then pink is a turn.
Pink. Oh, pink. Stop. Okay, pink is a turn. Pink is a turn. I don't know what yellow is.
Okay, which direction turn though? Can you tell us? Is it predictable?
Yes.
It's a left. You think pink is a left turn?
Pink is always a left, no matter what you want.
Okay.
Alright.
So if you guys were going to pick one of these to make, can you make your little card go into a square? Wait, figuring out which direction to go, which codes. Or figure 8?
Think about which tiles you would need to use to make that square, and we'll check back with you in a few minutes
We're
and
going to
see
give
how
you
it's
guys
going.
the square.
All right, next group. Can you tell us a little bit about what you've learned so far?
So we realized that the green, it goes forward.
Okay.
So the teal, the blue goes right, and then this is like diagonal, right?
So, go ahead.
Purple, like, kind of like, makes kind of like spin around.
Yeah, we call that the happy dance, the celebration. So I have a question. I noticed that you've got the tiles all touching one another. Do you think that it's possible to still have Indy follow the directions with some space between your tiles? Have you tried that yet? Will it go on the carpet from tile to tile?
Actually, we sort of tried that. It
And
works.
how's that?
It works. Yeah. We're gonna need it right. It'll keep going. It'll keep on going. We don't have another. Yeah. Wait. We'll just keep going. Yeah. Like, okay. Be a bit closer.
Yeah, cool. All right, so when you get a chance, you can go ahead and select a
Pick
code.
one of those to try and do their square, the Z, the figure 8, or the...
All right, so tell us a little bit about what you've learned.
We learned that green means go. Oh yeah, we gotta start off. We have to start off with green. Green means
Go. What else do you know?
orange is diagonal.
Or what do you mean by diagonal?
Like it doesn't go straight, it just goes like to a
Okay.
No, it would be the same thing.
What else did you learn? Happy Turbo. Have you noticed if any of the tiles have anything to do with speed?
Try teal.
Might it make the car go faster or slower?
Teal probably.
Okay, well, let you work on that. Oh. Okay. All right, so we'll come back. We do. All right, guys, how's it going?
Good, yeah.
So tell us what you've learned so far.
So, okay, so blue takes it right.
Orange makes it go like diagonal.
Orange makes it go diagonal. Yep, teal also
Yellow
does
slows it down. Red stops it. Pink made it turn left.
that. Yeah, and green is just making it go forward, straight. So we've already made like a box shape.
Teal makes it go diagonal. Teal makes it go
I
diagonal.
have a question. What happens if it's upside down? Does it work?
Yes, it does. It does work. Okay. Yep.
All right, that's always something to try. So, based on our chart across the room,
You guys see that chart down there?
which pattern do you think you'd like to code for? Do you think you know enough now to be able to create
Yes.
one of those?
Definitely.
All right, let's see it.
Okay.
All right, well, Michelle, they got their brains going today. All kinds of steam happening. So, again, October...
We're steaming.
Yeah. October 19th, 9 to 11:30.
Yes.
And you'll see all of these exhibits plus many more. And then if you want to see any of these exhibits or the activities they finished today, just check out Do the Math social media, and then you'll see some of these projects done. Thank you so much for being here.
It's been an absolute
Super
delight.
fun. All right, back to you, Mike. Thanks.
Thank you, Sam. Thank you, Michelle. And KCSOS STEAM and Expanded Learning right there. All right, that event's coming up Saturday. But right now we have one final look at the bread and culinary calculations.
All right, so while that is in our mixer, let's talk about hydration on these whole wheat dinner rolls. Now, hydration for you is keeping the right amount of water in your body so that you don't get all crusty. Hydration for bread is similar. So what we're talking about here is how much water is in our dough. If we're making this into a fraction, we know that we're looking for the amount of water in our dough. So we know our water is going to be on the top. We have 1,000 grams. So we know we have 750 grams of our Joaquin Oro from Fat Uncle Farms, and we know we have 500 grams of our white bread flour. We're gonna add those two up to make our dough. So we have 1,250 grams. Now we're gonna divide 1,000 by 1,250, and we get 80%. We get 0.8. Now if you translate 0.8 to a percentage, we move our decimal 1 2 places, and now this becomes 80%. That's how much water is in our dough. Our dough is made up of approximately 80% water. Now that doesn't mean that the other 20% is flour. That just means if you're comparing the amount of water to the amount of flour, you have 80% of the amount of flour in water. What you're looking at here, all these little strands, these spots where the dough is breaking, all those are gluten molecules that are coming apart. Now this is what makes your bread chewy, gives it those bubbles. So we need to get this dough out and into a greased bowl. We have a little spray here of just water and oil. Very simple. That's just gonna keep the dough from sticking while we're letting it proof. Got my bench scraper here, which functions as a bowl scraper on the other side. We're just gonna get this dough out and into our bowl. We are done with our mixer now. We can wash our mixer. But before we let this dough rest, we are going to give it a fold. Now, it's pretty much what it sounds like. We're gonna stretch our dough, fold it over, turn 180 degrees, stretch the other side of our dough, and fold it over. Now we're turning it 90 degrees. So as you can see, we've now done one side and the other side. Now we're gonna switch to these two sides. We're going to stretch our dough and fold it over. And 180 degrees, stretch our dough, fold it over. You can already see that this is becoming a smoother, shinier dough just from those 4 folds. We're gonna let this dough rest. We're gonna come back in an hour and do it again. Now I'm gonna go to my C shape, and we're just going to roll this dough until we get a tight skin.
Everybody loves bread. All right, Caitlin, you ready to get to work?
Yeah.
All right, you have to find 3 numbers where if you take a number and you square it, the result has 3 digits in it.
Okay.
But you cannot repeat any of the digits that you put on that 3 by 3. So if I did 11 squared, what would that be?
121.
And we couldn't use that because you'd have 2 ones up on the board. You have to use all the numbers 1 through 9.
Oh, okay.
And when you get a 3-digit number and all 3 of the digits are different, you're going to put the 3 numbers up there. It doesn't matter where you put them. We're just going to use all 9 digits. So you and Scott, go ahead. You've got a calculator, and I'm going to give you 3 minutes.
Where do you want to start?
Find 3
Any
numbers.
ideas? What numbers? First of all, could you use the number 7? What's 7 squared?
49.
That wouldn't work, right? So what's the lowest number you could possibly use?
10.
10, right? 10. But 10 is 100, and that has 2 zeros. That doesn't work.
Right.
So we got to at least start at 10. So the lowest number we could possibly be would be that. In other words, the range of these numbers. What's the highest possible result you could have? 999, right? So the answers that we have in here have to be somewhere between 100 and 999, right? If we end up doing a number squared, it ends up being bigger than 999, it's not going to work, even if the numbers seem to like they want to work out for us.
Here's a hint for you. Do you know what season we are in for Do the Math?
23.
Ooh, how do you know that?
The glasses.
Oh, that's right. You took a photo with the glasses. All right. What's 23 squared?
529.
Put that up there.
Does that report
somewhere.
any of them?
See, that'd be
Repeat any
a
of
good
them?
Yeah.
start.
No,
Okay.
it doesn't.
So we'll put it right here in the middle. What did you say? It was a 529.
And 29.
Okay, so we've used 5, 2, and 9. We have
So I'm
1.
going to give you another clue.
So we
Oh my
have
gosh. We're getting
To help
clues
you out here,
everywhere.
sister, all right? So, if the Yankees win this year's World Series, how many World Series would the Yankees have won if they win this year?
Wow.
Oof.
It's higher than 23. They dominate.
Is it in the 30s?
Nope.
27.
That's how many they have right now.
Oh, 28.
So try
28.
that.
Okay.
See if that works. What's
Oh.
28 squared?
28 squared. 784.
Will that work with all of your numbers?
Yes.
Okay. Because none of them are repeated now, are they?
Yeah.
So
Well,
see what numbers are left
Yeah, what digits are left on them?
and see if you can figure it out.
1, certainly. 3, What's the last digit that's left?
4.
You've already
Oh, no. Sorry. This is simple. I don't know why I don't know this.
1, 3, and
Oh, it's 6.
6. Gotcha. Can you think, is 136 a square? Say no.
No.
That doesn't work out. How about 163? What's 12 times 12?
144.
Not quite there. What's 13 times 13?
169.
Oh, so close. So that doesn't work either. So it's probably not going to start with a 1 is my thought,
So maybe
right? So it's either going to be,
So it's going to be in the teens. It's going to be in the high teens, I'll tell you that.
Right. The number that's squared here,
Right.
the number he's talking about that's squared, he says is
Okay.
going to be in the high teens. You know what 15 times 15 is? That's a good one to memorize. Just like you memorized 1 through 12, I'm sure.
Yeah.
15 times 15 is a good one to memorize too.
225.
That's
Right.
right. So that
But
won't work either, but it's going to be, so it looks like it's going to be higher than 15.
I want to try 17.
Give it a shot. Now, what's 7 times 7?
49.
Right. That ends in a 9. So 17 times 17 is going to end in a 9. We don't have a 9 to play with.
Oh,
So
okay.
let's try a different one.
What
Eight.
is 8 times 8?
18.
8 times 8. 8 times 8 is what?
64.
64. It's going to end in a 4. We don't have that one either.
Try your last
What's
teen.
9 times 9?
81.
81. We have a 1. Okay, let's try it.
So 19.
19 times 19?
361.
3, 6, 1. Oh my gosh, it's almost like it worked out like it's supposed to.
There you go.
Those Yankees help you every
Nicely
time.
done.
I'll tell
All
you
right,
what.
come on over here, young lady. Hey, don't forget, this Saturday, Steam on the Street, October 19th. You get more information on our social medias pages. And also, Via Arte is coming up. That's coming up the 19th and the 20th. That from the Bakersfield Museum of Art, great friends of ours. Do you know how to do one of these?
I don't.
You don't?
No.
Good, so I'll mix one up for you, give you something to do for a couple days. Have you ever seen one like that? Do the math on it?
No.
That is slick, isn't it? That is pretty slick. So you get it all one side, do the math. Did you learn a little something today?
I did.
That's exactly what we wanted you to do. But even more importantly, did you have a little bit of fun today?
Yes.
That's the most important thing right there. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.